Hello everyone, thank you for watching my poster presentation. I am Gustavo Ruiz and I will talk about the Triborheological analysis of gastrointestinal forcing mucus and polymeric nanoparticle system for studying mucoadhesion. First of all, it's important to mention that mucus is a viscoelastic hydrogel that coats every wet epithelial surface in our gastrointestinal tract. The importance of this natural polymer is that it develops key roles in the functionality of our gastrointestinal tract. It protects the tract for external pathogens or particles such as toxins. As well, it has some lubricant properties that that are really important during the digestion procedures and for cleaning the tract. And even the mucus has a key role in keeping the proper hydration of several organs such as stomach or intestines. Mucus is conformed by 90% of water and 10% of an polymeric network, in which the most important protein is mucin, which is around 5% in concentration of the total mucus. The mucin is important because it's intimately related with the viscoelastic properties of mucus, and these viscoelastic properties are really important to develop all the biological functions that mucus has. Otherwise, mucin exhibits some pH-dependent behavior, so it's important to know how the pH modify its behavior in order to see if the interaction with some external particles, like chitosan nanoparticles in this case, could modify or alter the functionality of the mucus. Because chitosan is a polymer, a cationic polymer that tends to exhibit some mucoadhesive properties with the mucus that is negatively charged. So in this case, my study is focused on understanding more about this mucoadhesion, but considering the pHs, the pH values that are around the gastrointestinal tract, because it could be really acidic in the stomach. Sometimes it reaches around 1 or 2 during active digestion, but it also tends to be more neutral or even a little bit basic in the intestines around 7, 8. For that reason, the main objectives of this project is to evaluate the viscoelastic properties or behavior of the mucus under different pH. I determined that pH 2, 4, 6, and 7 are a good parameter to observe how the behavior is changing when the pH is increasing. And the second objective is to study how the mucoadhesion is altering the viscoelastic properties and mainly the viscosity of mucus under the gastrointestinal pH conditions. In the methodology, first of all, I prepare some reconstituted mucus samples. I consider the 5% concentration of mucin in order to replicate something similar to the natural or native mucus. In the preparation as well, I incubate the sample during 24 hours at 37 degrees and 200 revolutions per minute in order to mimic the natural condition. At the same time, I prepare some chitosan nanoparticles that then I mix the the mucus with the solution of chitosan nanoparticles. I use 1:1 proportion. I adjust the pH to see the different pHs, 2, 4, 6, and 7, and then I perform all the rheological tests. Finally, I analyze the results, and I have some graphs that I will show you. So in figure 1, I show to you the scanning electron microscopy images of the chitosan nanoparticles. These nanoparticles exhibit an spherical shape with a mean size around 221.4 nanometers and a polydispersion index of 0.45. As well, is important the zeta potential, that is 26.9 millivolts, which means that our nanoparticles are positive, are cationic, and also it exhibits some stability that will be good in terms of the experiments. After that, the rheological experiments were performed. First of all, the mucus were tested alone in order to see how the viscoelastic properties behave. And in figure 2, we observe the viscoelastic behavior. The black dots are pH 2, the red squares pH 4, the green diamonds pH 6, and the blue triangles pH 7. As we can see in the figure, only the black dots has a very important difference between the filled figures and the empty figures. It means that they have a very elastic behavior because the G prime is always dominant over the viscous behavior, that is the G double prime modulus. But in the other values, even the pH 4, 6, or 7, we observe that the values between the G prime or elastic modulus and the G double prime or viscous modulus are very similar. Even they change. Sometimes the viscous modulus is a little bit higher, but on other frequency values, the elastic modulus is the dominant. Not is clearly dominant, but they have some changes between the dominance of the modulus. It means that at these values of pH, the mucus exhibit a polymeric solution behavior that is more related with something liquid, and during the pH 2, the acidic condition, that the elastic modulus was dominant, clearly dominant, we say that it has a weak gel behavior. That is expected because mucin, that is the main responsible of the viscoelastic properties of mucus, exhibit an isoelectric point around 3. So the change in the conformation of the mucin is about that value. So they pass from elastic gel, weak gel, to a polymeric solution. That it's also important because at acidic pH, the idea is to protect the stomach for being auto-digested. And in the more neutral condition, the idea is to act as a lubricant to help the digestion procedure. Then in the figure 3, we observe that it doesn't matter the pH, the behavior is a shear thinning behavior, which means that when the shear rate is increasing, the viscosity of the samples are decreasing. This is related with some lubricant properties that they are needed in our gastrointestinal tract, and we observe when the shear rate is very high, around 1000, when the pH is more neutral, it exhibits higher viscosity, so the lubricant properties are better. Then in figure 4, we observe the tribological profile of the mucus alone, which is very related with the viscous profile of figure 3, because when the pH is very acidic, that is the case of pH 2 in the sample that has the black line, the coefficient of friction is higher. But when the mucus exhibit some pH conditions related with more neutral values, 6 and 7, the coefficient of friction is lower because it has better lubricant properties, as I mentioned in figure 3. So it's only like a confirmation of the information that we get through the viscous profile. Finally, in figure 5, we get the rheological synergism test in order to see how is the mucoadhesive profile of the chitosan nanoparticles. In this case, the mucoadhesion profile were only test for neutral pH, that is 6 and 7. In the figure, we observe the black dots that are related with the viscous profile of nanoparticles alone. The red squares are related with the profile of mucus alone. The blue triangles are related with the viscous profile of the summatory of mucin and chitosan profiles. And finally, the green diamonds are the viscous profile of the mixture of these polymeric nanoparticles with the mucus. It's important the difference between the mixture and the summatory. This difference shows to us that there is some synergistic interactions between both polymers, and we assume that there is some adhesion between them. So at neutral pH, the chitosan nanoparticles exhibit a high value of adhesion. And probably that would be a good option for drug delivery properties using chitosan nanoparticles. So finally, we get some conclusions that the confirmation that mucus exhibit a pH-dependent viscoelastic behavior, that the reconstituted mucus behaves as an elastic gel under highly acidic condition, but at neutral pH, they act more like a viscous polymeric solution. As well, the viscosity curve shows a non-Newtonian shear thinning behavior independently of the pH, while the striped curve indicates that reconstituted mucus has poor lubricant properties compared with the native mucus, but the coefficient of friction shows us that the acidic pH has the lowest lubricant properties. And finally, the Rheological synergism showed that chitosan nanoparticles exhibit a high degree of mucoadhesion with reconstituted mucus at neutral pH. The next step is to perform this rheological synergism under the acidic pH, that is pH 4 and 2, in order to see which could be the best option or alternative for possible drug delivery activity. And as well, even when the rheological synergism shows us a very high degree of mucoadhesion, it's important to complement these results with another technique that could be AFM or flow through method, ellipsometry, among other different techniques. Thank you again for watching this poster and continue enjoying the Congress.